Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is a continuation of a lecture for intermediate algebra on the quadratic formula. This is part D of that lecture, so in this part we're going to focus on the discriminant. And for most students, this should be your first introduction to this idea of the discriminant. It's actually a pretty interesting idea. I've seen very, very unique uses of it by students in my classes. As with all the previous lectures, I just want to remind you of the quadratic formula here. Specifically, one little part of this quadratic formula that is the most important part we're going to talk about in this lecture, that's the b squared minus 4ac part. It turns out that that's what we call the discriminant. So we define the discriminant to be b squared minus 4ac for quadratic equations of the form ax squared plus bx plus c is equal to 0. And the reason why we want to label this specifically is because it allows us to determine the kind of solutions that our equation has. For example, suppose that in our quadratic equation we have that b squared minus 4ac turns out to be positive. In other words, if you look at the quadratic formula, the stuff underneath the square root here is positive. What that essentially implies is that we have two real solutions. Not only do we have two real solutions, but they're two different real solutions. And that's because this number underneath the square root is positive and it's greater than 0. So you have something like a negative 1 plus or minus the square root of 3 over 2 or something like that. We get two real solutions, negative 1 plus root 3 over 2 and negative 1 minus root 3 over 2. So this implies two real solutions. If, on the other hand, b squared minus 4ac is actually equal to 0, well then our solutions would be of the form negative b plus or minus the square root of 0 over 2, or in other words, just a negative b over 2. So seemingly we would have a single solution, like a negative 1/2 or a negative 5/2 or something like that. So it looks like we have one real solution. However, there is a little note on this, that in this case we would say that our solution has multiplicity 2. And the idea of multiplicity does not really come up for a while in a normal intermediate algebra course. But essentially it's saying this, that your original quadratic equation could have factored down to, like, let's say x minus 1 squared is equal to 0. The solution to this is 1, right? It seems like we only have one solution, but the fact is we actually have two versions of that one. In other words, one solves it, but this power says it solves it twice. Okay. It's not that important right now, but it comes up later on in a course for intermediate algebra. Specifically for graphing, it helps out quite a bit. So let's see, we've had the case where our discriminant, b squared minus 4ac, is positive. We get two real solutions. If it's equal to 0, then the stuff underneath the square root turns into 0, so we have one real solution. And then finally, if b squared minus 4ac is less than 0, or in other words, negative, well then, in this case, we will have some negative number underneath the square root. And so in this case, we will have, I should probably have written 2a there, 2a there, and 2a down here. Oh, that didn't have 2a. Anyway, sorry about that. It turns out that if you have a negative underneath the square root, that you have complex solutions, right? Complex number solutions. So this implies that you have two complex number solutions. And they will be complex conjugates. In other words, if 1 plus 2i is a solution, then 1 minus 2i is a solution. Now, honestly, I've seen some very great uses of the discriminant. It essentially allows you, before you do any heavy calculations, to determine if you actually have a real solution or not. If you're only concerned with having real solutions, then it's great to use the discriminant first to check whether or not you even have a real solution. So here's 3 different quadratic equations, and all we want to know is how many solutions and of which type are our solutions for each of these quadratic equations. So let's go ahead and look at example A. I have to rewrite this, first of all, to be 3x squared minus 17x plus 26 is equal to 0. And remember, the discriminant is just b squared minus 4ac, and that's going to allow us to determine how many solutions there are and of what type. So that's going to be negative 17 squared minus 4 times 3 times 26. Now, I'm not really too concerned about what the actual number is. I'm more concerned about whether it's positive or negative. So let's do 17 squared and then minus 4 times 3 times 26. That's a negative number. And that's really all I care. I don't really care what the number is, unless I'm actually trying to solve this, but I'm not really trying to solve it. All I want to know is the discriminant positive, equal to 0, or less than 0? And here it's less than 0, which implies we have 2 complex number solutions, right? And that essentially tells us, if this was for some real application where we wanted real number solutions, this means that there's no possible way we get real solutions. We have a square root of a negative number. So now let's look at part B. We'll just do this for each of them. Part B is already set up here for us, so I'm actually just going to drag the calculator over and do part B via calculator without writing anything down. Remember, it's b squared, it's b squared, which is going to be technically a negative 712 being squared, but the negative doesn't matter actually. So 712 squared minus 4 times a times c. Oh, that's exactly 0. Oh, how convenient. So I see our discriminant b squared minus 4ac is equal to 0, and that implies that we have just a single solution because the square root disappears in our quadratic formula. So this implies one real solution. Although still kind of an interesting result is that that real solution is of multiplicity 2. Again, it's like saying that you've factored a quadratic equation and got it to factor as x plus 3 times x plus 3. That means that negative 3 is a solution of this, but it happens twice. That's what this is saying, is that you have a real solution, it just happens twice. And finally, this last one, and I have to rewrite this in standard form. 13.2x squared minus 65.2x plus 41.7. So let's go ahead and check this. I'll just move a calculator over here. Remember, it's b squared, so 65.2 squared minus 4 times a, 13.2. Oops. Clean that up. 13.2 times c, which is 41.7. And I get a very large number, actually. So in this case, it's much greater than 0, which implies that we have 2 real solutions. We're taking square roots of real numbers, or positive numbers, I'm sorry. So we have 2 real solutions. And for now, that's all you really need for discriminant. It just helps you determine how many solutions you have. Great for applications and other really kind of interesting things.